Hi guys, welcome to today's tutorial. Today we'll be looking at top GCE mathematics questions. Alright, our first question says solve 3x plus 7 greater than or equals 2. Now, to solve this, we are going to find both the positive and negative aspect of this, of our 2, to become 3x plus 7 greater than or equals to plus or minus 2. Alright, now expanding this and solving this out, this will give us 3x plus 7 greater than or equals to 2, or 3x plus 7 greater than or equals to minus 2. Now, collecting all like terms together, we are having it as 3x greater than or equals to 2 minus 7, or 3x greater than or equals to minus 2 minus 7. Now, this will give us 3x greater than or equals minus 5, or 3x greater than or equals minus 9. Now, dividing all through by 3, this becomes 3x over 3 minus 5 over 3, or 3x over 3 minus 9 over 3. So from here, our x will be greater than or equals minus 5 over 3, or x is greater than or equals minus 3. So this gives us the value of x. And next question says, by completing the square, write x squared minus 4x plus 12 in form of, we should write it in form of x plus a squared plus b. Now, in using completing the square method, we'll first of all move our constant over to our right hand side. This will give us x squared minus 4x equals minus 12. All right, now the next thing we have to do in completing of square method is divide the coefficient of x by 2 and square it. So if our coefficient of x of x is minus 4. All right, so if we divide minus 4 by 2, that gives us minus 2. So we square it, that will give us 4. All right, so introducing 4 into this equation, that becomes x minus 4x plus 4 equals minus 12 plus 4. All right, now for us to eliminate this, we'll replace with 2 squared. That will become x minus x squared, x minus 2 all squared equals minus 8. Now returning this back to equate this equation to 0, we would have it as x minus 2 all squared plus 8 equals 0. Now in this situation, we've written it as this, where our a equals minus 2 and b equals 8. The second aspect of the question says, hence, describe two successive transformations which map the graph of the function y equals x squared to the graph of the function y equals x squared minus 4x plus 12. Now, we earlier saw that x minus 2 all squared plus 8, equals 0 from the first part of the question. Now, for y equals x squared to y equals x minus 2, this shows that there's an increase by 2 units. There's an increase by 2 units on our x-axis, and for y equals x squared to y equals x minus 2 squared plus 8. This shows that there's an increase by 8 units. So the two successive transformations will be that on our x-axis we have it 2 units increase and 8 units increase. So there's an increase of 2 units for our first aspect, and there's an increase of 8 units on our second aspect. Our next question says expand 1/4 minus x squared in the binomial series up to and including the terms in x cubed. Now, if we are expanding this will become 1/16 bracket 1 minus x/4 all squared. All right, now let's expand this as, let's expand our 1/1 minus x/4 all squared in binomial. Now, expanding this, we're having 1 plus nz plus n bracket n minus 1, n plus 1 all over 2 factorial z squared plus n bracket n plus 1 n plus 2 all over 3 factorial z cubed. Now, where z equals x/4 and n equals 2. All right, now substituting this in here, we are having it as 1 plus 2 bracket x/4 plus 2 bracket 2 plus 1 all over 2 x/4 all squared plus 2 bracket 2 plus 1 2 plus 2 all over 3 times 2. All right, x/4 raised to power 3. Now this becomes 1 plus 2x, okay, x/2, 2 here 1, 2 here 2, so x/2 plus 3 x squared all over 16 plus 2 we cancel 2, 3 we cancel 3, leaving us with 4x cubed all over 4 times 4 times 4. That will give us 16 times 4. 4 times 6, 24, rather than 4. That will give us 64. All right, from here we have it as 1 plus x/2 plus 3x squared over 16 plus 4 here 1, 4 into 16, 4 into 64, 16. So this gives us x cubed over 16. All right, now recall that we have 1/16 kept aside somewhere. So we multiply through by 1/16. So this becomes 1/16 bracket open 1 plus x/2 plus 3x squared over 16 plus x cubed over 16. Opening up this bracket, we have it as 1/16 plus x over 32 plus 3x squared over 16 times 16 would give us 256 plus x cubed over 256. So since we are asked to raise it including in the terms of x cubed, so we've brought it to x cubed. So this gives us our answer. Our next question says express 4x squared minus x plus 7 over 2x minus 1 x plus 2 in partial fractions. Now, if we want to express this in partial fractions, this will become a over 2x minus 1 plus b over x plus 2. All right, from here, would equate this to our numerator. This will become 4x squared minus x plus 7 equals, cross multiplying this, a x plus 2 plus b 2x minus 1. All right, opening this up would give us our 4x squared minus x plus 7 equals ax plus 2a plus 2bx minus b. Now, collecting our terms together, this we are having it as 4x squared minus x plus 7 equals this, collecting these two terms together, this becomes ax plus 2bx plus 2a minus b. Okay, so from here, x will become, x is common here, a plus 2b, and this is common, 1 is common here, this becomes 2a minus b. So from here, we expand the denominator, 2x minus 1, x plus 2. Now this will give us 2x bracket x plus 2 minus 1 bracket x plus 2. Now expanding this, we will be having it as 2x squared plus 4x minus x plus, minus times minus, minus times plus minus 2 times 1, 2. So this will give us 2x squared plus 3x minus 2. Now replacing this here, this will have, we are having it as 4x squared minus 7x, minus x plus 7 all over 2x squared plus 3x minus 2. Now we can see that these are having same sign. So we can now say, equating our x squared, this becomes 4x squared over 2x squared. So our value will become 2. Now, this 2, we'll use it in multiplying our denominator to find out the missing fraction in the numerator. So now multiplying our denominator by 2, this becomes 2x squared plus 3x minus 2 times 2. We'll have it as 2 times 2, 4x squared plus 6x minus 4. Now, this will subtract from this, our numerator. So now we'll have it as 4x squared minus x plus 7 minus 4x squared plus 6x minus 4. All right. Now, if we open up the bracket, we are having it as 4x squared minus x plus 7 minus 4x squared minus 6x plus 4. All right. This, we cancel out this, leaving us with minus 7x plus 11 as our remainder. Now, we now substitute back into this. So this becomes minus 7x plus 11 all over our 2x minus 1 and x plus 2 equals a plus b x 2x minus 1 and x plus 2. Now, if we look at this, we can now record that from here, we have it as our x, our a plus 2b bracket x, okay, which is this, will give us a minus 7. Okay, that's the coefficient of x. So a plus 2b will be equals 7x. So if we cancel out our x, our a plus 2b will give us minus 7. Okay, now from our other part, here we have 2a minus b would give us 11. From here, let's call this equation 1, equation 2. So from equation 1, we can say that a equals minus 7 minus 2b. All right. Now, substituting value of a into equation 2, this becomes 2 bracket minus 7 minus 2b minus b equals 11. All right. This will give us minus 14, opening up the bracket, minus 4b minus b equals 11. Now, collecting like terms, we have it as minus 5b equals 11 plus 14. So minus 5b equals 25. So therefore, our b equals 25 over minus 5. So the value of our b will be minus 5. Now, knowing that our b is minus 5, we can now substitute the value of b into our equation 1. Now, a plus 2b equals minus 7. Now, this will give us a, all right, a equals minus 7 minus 2b. Now, the value of b is minus 5. So this becomes a equals minus 7 minus 2 bracket minus 5. So this will give us a equals minus 7 plus 10. So a equals 3. So our partial fraction will become 3 over 2x plus 1 plus b, which is minus 5, minus 5 over x plus 2 will be the partial fraction for this. If you've watched up to this moment, don't forget to like, subscribe, and click on your notification buttons for more updates. A curve is described by the parametric equation x equals 2 cot theta and y equals 3 minus sine theta. Now, for x equals 2 cot theta, our cot theta will become x over 2. But we know that cot theta is cos theta over sine theta. All right, now working around this becomes cos theta over sine theta equals x over 2. So our cos theta will become x over 2 sine theta. Okay, from here we know that sine squared theta plus cos squared theta equals 1. Okay, replacing this for this becomes sine squared theta plus x over 2 sine theta squared equals 1. Now, opening up this bracket, this will give us sine squared theta plus x squared over 2 squared will be 4 sine squared theta equals 1. Now, from here, we have common terms, which is sine squared theta. So this will become sine squared theta, bracket open, 1 plus x squared over 4, okay, equals 1. So our sine squared theta will be equals 1 all over 1 plus x squared over 4 as our sine squared theta. Okay, from here, if we open up this bracket, if we have 1 over 1 plus x squared over 4, okay, our LCM will be 4. This becomes 4 plus x squared, okay? Now, having this way, we can now replace this here as sine squared theta equals 1 over 4 plus x squared over 4, okay? Doing our multiplicative inverse here will give us our answer as 4 all over 4 plus x squared. So recall, we have y equals 3 minus sine theta. Okay, so sine theta equals 3 minus y. So if we square both sides, this becomes sine squared theta equals 3 minus y squared, all squared. Okay, now bringing this and this together, that will give us 3 minus y all squared equals 4 over 4 plus x squared. Now, that is the Cartesian connection connecting our x and y. Now, to the second aspect of the question, it says find the point where the curve crosses the x-axis on x minus equals 2 cos theta and y equals 3 sine theta. Now, we know that on our y-axis, x equals 0. So this becomes x equals 2 cos theta. Okay, so this is 0 equals 2 cos theta. So cos theta equals 0. So theta equals cot inverse of 0. Okay, which will give us pi over 2. All right, and we know that pi over 2 is 180 over 2, which is 90 degrees. All right, now bearing in mind that pi over 2 is theta, now to y equals 3 minus sine theta, where theta is pi over 2. Okay, this gives us y equals 3 minus sine pi over 2. Okay, now this will give us y equals 3 minus 1. Okay, sine pi over 2 is something as 180 over 2, which will give us 90 degrees in degrees. So sine 90 will give us 1. So y equals 2. So the point where the curve crosses the x-axis will be when x is 0, and our point will be when x is 0 and y is 2. Will give us the point it crosses the y-axis. Differentiate in x minus 1 all over 3x squared and simplifying your answer. Now, for us to work on this, we'll use our quotient rule, which is v du minus u dv all over v squared, where let u equals in x minus 1, so our du will be 1 over x, and v equals 3x squared, and the dv will be 6x. Okay, now substituting this into our quotient rule, our v is 3x squared times 1 over x minus u, which is in x minus 1, times dv, which is 6x, all over 3x squared, all squared. Now, expanding our bracket, we're having it as 3x squared over x minus 6 in x, 6x in x minus 6x. All right, all over 9x raised to the power 4. Okay, now this will cancel one of these, leaving us with 3x minus 6x in x plus 6x all over 9x raised to the power 4. Okay, now collecting our like terms here would give us 9x minus 6x in x all over 9 raised to power x raised to power 4. Okay, from here we can still simplify this by collecting our like terms. What's common here is we can bring out 3x is common. Okay, 3x is common. If we remove 3x from here, we have 3. If we remove 3 from here, minus 2x, 2 in x, all over 9x raised to power 4. Okay, so this, we cancel this to give us 3 minus 2 in x, all over 3x raised to power 3. Find the integral of e2x minus minus x all squared all over e raised to power x dx. Now, let's first of all expand this. If we expand this, we have e2x minus e minus x all squared. This will give us e2x minus e raised to power minus x times e2x minus e raised to power minus x. Okay, now opening this times this will give us e raised to power 4x. This and this will give us minus e raised to power 2x minus x minus e raised to power 2x minus x plus this times this will give us e raised to power minus 2x. All right, now from here, closing up this, we have e raised to power 4x minus e raised to power x. So same thing with this. So this will give us 2e raised to power x plus e raised to power minus 2x. Now replacing our numerator with this will give us our integral of e raised to power 4x minus 2e raised to power x plus e raised to power minus 2x all over e raised to power x dx. Okay, now having this, let's differentiate, separate this division for each and every one of these. Now this becomes e raised to power 4x over e raised to power x will leave us with e raised to power 3x. All right, and for this we have 2e raised to power x over e raised to power x will leave us with, okay, minus 2 will leave us with minus 2. And for this we have e raised to power minus 2x over e raised to power x, which will give us e raised to power minus 2x minus x, which will give us e raised to power minus 3x. Okay, now from here we differentiate each and every one of them. So doing our dy dx, the x of e3x dx will give us so now integrating this and finding this dx, this will give us 1 over 3 e3x. All right, and for this other one we have a minus integral of minus 2 dx will give us a minus 2x, and the integral of our e minus 3x dx would give us a minus 1 over 3 e minus 3x. Now bringing this all together, we are having it as 1 over 3 e 3x plus, okay, this becomes minus 2x minus 1 over 3 e minus 3x plus our constant. So with this, we've integrated our question. Evaluate sec squared x plus sine squared x plus cosec squared x plus cos squared x minus tan squared x minus cot squared x. Now, we know that sec squared x is 1 plus tan squared x, and cosec squared x is 1 plus cot squared x. Now replacing this for this and this, we are having it as 1 plus tan squared x plus sine squared x plus 1 plus cot squared x plus cos squared x minus tan squared x minus cot squared x. Now, tan squared x will cancel tan squared x, and cot squared x will cancel cot squared x, leaving us with 1 plus 1, 2 plus sine squared x plus cos squared x. Now, record also that our sine squared x plus cos squared x equals 1. So that means these two will be equated to 1. So this will become 2 plus 1, which will give us 3. So 3 is our answer to this equation. Solve 7 sec theta minus 8 equals 2 over cot squared theta. Now, where your theta ranges from negative pi to pi. All right. Now, we know that sec theta equals 1 over cos theta, and cot squared theta equals cos squared theta over sine squared theta. Now, replacing this for this and this for this, we are having it as 7 sec theta times 1 over cos theta minus 8 equals 2 all over cos squared theta minus sine squared theta. Okay, now this is going to give us 7 over cos theta minus 8 over 1 equals 2 sine squared theta all over cos squared theta. All right, so if we expand this, this will give us a cos theta all over 7 minus 8 cos theta, okay, equals 2 sine squared theta over cos squared theta. All right, now cancelling out, cross multiplying it or cancelling out will give us 7. Expanding, opening up this becomes 7 over cos theta times cos squared theta minus 8 cos theta over cos theta times cos squared theta equals 2 sine squared theta. Now, this will cancel one of this, leaving us with 7 cos theta minus 8 cos squared theta. This will cancel this, equals 2 sine squared theta. Now, we know that sine squared theta plus cos squared theta equals 1. So our sine squared theta equals 1 minus cos squared theta. Now, replacing that here, we'll be having 7 cos theta minus 8 cos squared theta equals 2 bracket 1 minus cos squared theta. Now, opening up this bracket, we have it as 7 cos theta minus 8 cos squared theta equals 2 minus 2 cos squared theta. Okay, now moving this over to this other side, we're having it as 7 cos theta minus 8 cos squared theta minus 2 plus 2 cos squared theta equals 0. Now from here, we collect our like terms. We have our 8 cos squared theta and 2 cos squared theta. So this becomes 7 cos theta. 8 minus 8 plus 2 will give us minus 6 cos squared theta minus 2 equals 0. Now from here, we can see we have a quadratic equation. So we can say let cos squared theta equals x. So replacing with x, this becomes 7x minus 6x squared minus 2 equals 0. So bringing this forward, minus 6x squared plus 7x minus 2 equals 0. So in order to eliminate this negative, we multiply this by a negative. So minus and minus will give us a plus 6. This becomes 6x squared minus 7x plus 2 equals 0. So from here, solving out our equation using our quadratic formula that says x equals minus b plus minus root b squared minus 4ac all over 2a. Now in this situation, our a is 6, b is minus 7, and c is 2. All right, substituting into our formula, this will have minus 7 plus minus 7 squared minus 4 times a, 6, times c, 2, all over 2 times a, which is 6. Okay, so from here, we're having it as 7 plus minus root 49 minus 4 times 2 is 8. 8 times 6 will give us 48. So 40 minus 49 minus 8. 49 minus 48 would give us, so our 7 plus minus root 1 all over 12. So this becomes 7 plus minus 1 all over 12. So this will give us 7 plus 1 over 12, or 7 minus 1 over 12. So this is 8 over 12, or 6 over 12. So we are having our x as 4 here, 2, 4 into 12, 3, or 6 here, 1, 6 into 12, 2. So we're having our x as 2 over 3, or 1 over 2. In terms of pi, recall that our cos theta equals x. So this becomes cos. So recall that our cos theta equals x. So our cos theta would be half, or 2 over 3. Now, in terms of pi, our cos half would be pi, negative pi over 3, or pi over 3. While for this other one, our cos 2 over 3 would give us, in radian, will give us 0. In radians, will give us 0 plus or minus 0.84. 8411. So this would be the value of our cos theta. So guys, with this, we've come to the end of today's tutorial. Don't forget to like, subscribe, and click on your notification buttons for more updates. If there be any questions, put them in the comment section below. Thank you.